Today, on exam prep, we shall be focusing on some simple mathematics questions and we're going to explain in details on how to solve them, so that when students come across them, they'll be able to what? To solve them easily. The first question I have here says 3 log 2 plus log 20 minus log 1.6. How do we solve? In my subsequent video, we've talked about laws of log reading. You can go and check it so that you can know how to apply those laws. But over here, the law we are going to apply says if you are seeing a question that is not having any base, the natural base that is supposed to be there is what? Is base 10. So this will help you make it easy. So you put your 10. Now, the law of logarithm that I'm going to apply here, you see this one, it's in a two-way form. That means it's not having a log direct number, it's having a number before the log. While these ones are just having the log 20 and the log 1.6. So we are going to break this one down before we now apply the what? The law of logarithm. But which law of logarithm are we applying here? It is very simple that whenever you see log having plus, our law of logarithm says pick a log and what? Change the plus to multiplication. Whenever I see the same log with the same base having minus, pick a log and what? Change the minus to also what? Division. But before we do that, let's break this down. That will give us 3 log 2 in base 10 plus log 20 base 10 minus log 1.6 base 10. Focusing on this, then that will give us these 3 coming up here. That was log 2 raised to power 3 base 10 plus log 20 base 10 minus log 1.6 base 10. We all know that 2 raised to power 3 means 2 times 2 times 3, which will give us log 8 base 10 plus log 20 base 10 minus log 1.6 base 10. Now they are all parallel, having the same log number and the base, log 20 and the base, log 1.6 and the base. So we pick, since they are having the same base, we pick one log and check the addition towards multiplication, the minus towards 2 division. That will give us log 10, log base 10, 8 times 20, all divided by 1.6. It will be solved further as 8 times 20 is what? 160 divided by 1.6. And if we take 160 divided by 6, divided by 1.6, this will give us 100. Now they are having 100 and base 10. We know that 10 and 100, they are in the same index. That means index of 100, the power of 100, which gives us log 100 should be in 10 raised to power 2 base 10. The same way that these 3 came here the other time is the way the law of logarithm says the 2 should to go to the back, which we should manage this place as 2 log 10 base 10 equals to 2 times, whenever we see a log of a number with the same base, we have the law of logarithm to say we change to 1, the same number with the same base. That will give us our final answer as what? 2. The second question here says, if I have log s minus log 2s minus 1 equal to 1, find x. So it's for x here. And like I first explained over here, I said whenever you are seeing a logarithm of a number without any base, the natural rule says the number is in what? Is in base 10. The logarithm is in base 10. That will make us put 10x minus log 2s minus 1 base 10 equals to 1. Which law are we applying? Very simple. The same base and we see a minus. We go to what? We change the minus to division, picking one log. Now give us log base 10 x divided by 2x minus 1 all equal to 1. So instead of having the 2 log, we have picked 1 log in base 10 and the minus change was division, while the addition change was multiplication. We have this here. What are we doing next? There's another law that helps us break it down. I used to call it triangular. It says whenever we are having log x log a base x equals to b, and log says we should do it this way. So I used to call it triangular. That means the x should raise b as a power equals to a. That's x raised to power b equals to what? A. Or the same way, a equals to x raised to power b. So it says this base should take the answer as power. This my base should take the answer as power equals to this one here. Now give us s over 2 s minus 1 equals to 10 raised to power 1. And when that 10 raised to power 1 is 1, s over 2x minus 1 equals to 10. What do? We what? We cross multiply. Cross multiplying here, we have x times 1 to be here and 10, because this one number multiplying an algebra, so we have to put the 2 together, the 2-term equation, which is binomial, into the brackets, so that the simple number can multiply the 2 of them. X times 1 will give us what? X equals to 10 times 2x, 20x, 10 times minus 1, that's minus 10. What do? We what? We collect like terms. Collect like terms. That will give us, and very, very important that we always, in the anytime we are solving collecting like term, let your unknown variable be at the left hand side. So bring all the x factors to the left hand side and the natural number to be at the right hand side. That will be x minus 20x equals to what? Minus 10. X minus 20x will give us what? We all know that this x is having a very constant 1, because x is 1x. So 1x minus 20x will give us minus 19x equals to minus 10. To get x, something is disturbing x, which is what? Minus 19. So we say what? Divide both sides by minus 19. That's in the disturbing x. So that's minus 19x divided by minus 19 equals to minus 10 divided by minus 19. I say my x equals to what? Minus 19, minus cancel minus, that's what? 10 over 19. If you look at this question, what is the hint? The same way. Looking at the denominator, we have the same base, that's log base 3, but the numerator is having log base 5, so they are not in the same base. So the only solution we can do here is just what? To solve the numerator in its own way and to solve the denominator together since they are having the same base. Then solving this one here, we see that this is in base 5 and this is a decimal number. But a decimal number is not always most time used in terms of indices. Then the better way is what? To convert to fraction. After converting to fraction, then we see that it will be easier from fraction to what? To an index, which is indices under the question here. Now over here we now have the log base 5. Our 0.04 will now be converted to what? To a fraction. That's 4 over 100 all over. We have the same base. So from the question we just finished, so they say the same base, we pick the base, one of it, and let's divide the number whenever it is minus. Now continue as the numerator, log 4. Okay, let's manage this place. This implies as log base 5. 4 in 100 give us what? 1 over 25. All over what? The log base 3. Log 9 in base 3. Yes, 1 over 25 is the same thing as log 1 over 5 raised to power 2. Because our base is in 5, so we can immediately change this 25 to 5. So that they can work together and the logarithm applies. Log 9 is also 9 and 3 are in the same index, which is index 3. That means power of 3. So 9 is 3 raised to power 2. All in base 3. The minus space, this implies as 5 raised to power 1 over 5 square is still the same thing as 5 raised to power minus 2. According to law of logarithm, that 1 over anything is what? 5 raised to power minus the power all over base 3. 3 squared, the same thing, 2 will come to the back and 3 will be here. Okay, this is base 5, sorry. Log 5 base 5. That will bring our 2 backward also. Log 5 base 5 all over 2 log 3 base 3. Managing this place again, that will give us minus 2 log 5 base 5. When logarithm in the same base will give us 1. According to law of logarithm, the same thing here. 2 times the number and the same base the same. We have it as 1. That will give us minus 2 times 1 minus 2 all over 2 times 1, which is what? 2. 2 here 1, 2 here 1. Our final answer is what? Minus 1 over 1, which is equals to minus 1. Final answer. The first question here says, s raised to the power minus 2 equals to 2 over 25. How do we solve? This is just like making s subject of formula, because whenever we are looking for s, we have to detach whatever is distracting s from it being free, so that s will give us as final answer. Over here we can see that s is attached with the power of minus 2 and at the same time attached with the 8 as the coefficient. The first thing we do is to remove the 8. So to remove 8 when it is attached by multiplication, we remove it by the inverse or by the opposite, which is what? Opposite of multiplication is division. So we say divide both sides by what? By 8. That gives us 8s raised to the power minus 2 divided by 8 equals to 2 over 25 divided by what? Divided by 8. So you take away 8. We have s raised to the power minus 2 equals to 2 over 25 times, change this 2 times. Whenever it is changed to time, we say we have the inverse. That is 1 over 8. S per minus 2 will give us 2 times 1 numerator to numerator, denominator to denominator. That is 2 over 25 times 6 will give us 200. S per minus 2 will give us 2 into 100, 1 and 100. That's 1 over 100. The same law of indices, whenever we are having 1 over, then the base, the denominator will be able to take it as inverse of the power. That's 100 raised to the power minus 1. And 100 is a number in index of 2, which is 10 raised to the power minus 2. So 10 raised to the power 2. And it's having its former power to be minus 1. This power law here will give us the power should multiply themselves. That's 10 raised to the power 2 times minus 1. That will give us minus 2. Looking at this here, I already say equating the base or equating the power. Then we see that our minus 2 take away minus 2, and over here my s is finally what? My s is finally 10. This is a question we solve in less than 40 seconds according to some external examination, maybe Jamb, like that, because of the time given to them to finish our question. When you divide, we see that it's just less than 40 seconds to solve. And this same base, we have minus. We say pick a base and a log, and once you change the minus to division, that's divided by 1 over 2. Our log base 5, 62 divided by 5, 62.5, sorry, divided by 1 over 2. Give us, we're just breaking this down. When division is changed to times, we have the inverse. That's 1 over 2 changed to 2 over 1. This is numerator to numerator, denominator to denominator. We have the log base 5, 62.5 times 2, give us 125 all over 1, which is the same thing. Log base 5, 125. Now you look at 125 and 25, which I used to tell my students that whenever I solve a question on that logarithm or indices most especially, get the table, the power table first. We have multiplication table, division table, addition table, and subtraction table. The same way we have power table. That will give us to understand that whenever we see 125 and 5, it's already inverse 5 raised to the power 3 base 5. Then we have it as 3 going to the back, as 3 log 5 base 5, which implies as 3 times log 5 is 5 to give us was 1, which is equals to what? 3 as final answer. That is all for today's video.